a little strange for me today. I want you to close your eyes, assuming you aren't driving or operating heavy machinery right now, of course. And I want you to summon a very specific image into your mind. I want you to visualize space-time. Just try to picture it. What do you see?
I mean, I feel like I know exactly what everyone listening is seeing right now. It's the grid, right? That black rubber sheet with the bright green laser grid lines dipping down.
Exactly. That is the image.
And there's usually a heavy bowling ball representing the sun sitting right in the middle of it, sinking down, stretching that rubber sheet out. And then maybe a smaller marble like the Earth, rolling around that curve, trying not to fall in.
It is the absolute classic image.
Yeah.
We have seen it in high school textbooks, on the Discovery Channel, in movies like Interstellar. It's the visual vocabulary we all use for general relativity. The bowling ball curves the sheet, and the sheet tells the marble how to move. It's elegant, it's intuitive, it just makes sense.
And to be completely fair to Einstein and the last century of physicists, it is mathematically accurate. That grid represents the geometry of the gravitational field. It predicts planetary orbits. It predicts the existence of black holes. It predicts the bending of light. It works.
And this is the massive show-stopping BIM that is going to drive our entire conversation today. What is the sheet actually made of?
Ah, that is the million-dollar question. Or, maybe the Nobel Prize question.
Right. I mean, is it rubber? Is it fabric? Is it made of energy? Is it a fluid? Or is it just nothing? Is it just abstract math floating out in a void?
If you ask a standard physicist today, they will likely tell you it's a manifold. It's a geometric relationship. It doesn't have to be made of anything material. It's a coordinate system. It's essentially the stage upon which the universe plays out, but the stage itself is ghost-like. It has no substance.
Well, today's deep dive is going to challenge that assumption fundamentally. We are looking at a framework that argues that this silence at the center of physics, this refusal to define the material substance of space-time, is the single biggest mistake in the history of science.
It is a very provocative stance. The argument we're looking at today suggests that we have entirely confused the map for the territory. We have a great map of the geometry, that's Einstein, but we have completely ignored the terrain itself.
And the answer this theory proposes isn't some exotic dark matter or a superstring from the 11th dimension that you need a multi-billion-dollar particle collider to find. The answer is something you probably interacted with 10 times before breakfast.
It's water.
Literal water.
Yeah.
H2O. The claim we are unpacking today is that the vacuum of space, the gravity holding you to your chair, the light traveling from the distant stars, it is all a property of a lattice water matrix.
We are diving deep into a set of papers by Garrick Ramsey Holmes, specifically the resonant shell cosmology and the lattice water matrix, and water as the physical substance of space-time. And I want to set the stage here immediately. This is a unified framework. It's not just a casual guess. It's a rigorous mathematical attempt to solve what Holmes calls the incoherent theory era of modern physics.
Right. Let's establish the mission of this deep dive clearly. Because usually, when we talk science on this show, we are talking about things that are firmly in the textbooks. We're usually summarizing the scientific consensus for you.
Correct. And we need to be very clear with our listeners right out of the gate. This is not in the textbooks. If you walk into the physics department at Caltech or CERN today and say, excuse me, is the universe made of water? You are not going to get everyone giving you 2 thumbs up. You might get security called on you, or at best, a polite redirection to the philosophy department.
So we aren't presenting this as the truth with a capital T that everyone agrees on. This podcast is absolutely going to point out where things are not matching up.
Exactly. This does not have the 2 thumbs up from the establishment, but that is exactly why we are discussing it. The source material explicitly points out where standard models are not matching up and are just plain wrong in the author's view. Holmes makes a compelling argument that standard physics has backed itself into a corner. We have string theory, which is mathematically beautiful but unproven after 40 years. We have simulation theory. We have the holographic principle. Holmes calls these applied incorrectly.
He says they're great math exercises, but they lack physical reality.
Right. He's saying we're lost in the weeds of abstraction. We are so obsessed with the equations that we forgot to ask what physical substance the equations are actually describing.
So our mission is to see if this theory, pun absolutely intended here, holds water. We want to do our best to explain exactly what Holmes claims is incorrect about our current understanding, the whole empty geometry thing, and what is corrected by this new framework, which is identifying the physical substrate as water.
And just a quick note for the listener. We're going to avoid using the word radical today because radical is often just a label we put on things that scare us or that we don't understand yet. It shuts down conversation. We're going to call this a revolutionary framework or a fundamental shift. We're reporting impartially on what the author is presenting.
A shift from geometry to substance. That is the core of it. So let's jump right into section 1, the core postulate. The headline of the paper is blunt.
Yeah.
It doesn't mince words at all. It says, space-time is identical to a three-dimensional lattice of water molecules.
And he means it literally. I think that is the hardest hurdle for people to get over initially. We are so used to metaphors in science, the river of time, the sea of stars, we naturally think, oh, he means it flows like water.
But he doesn't mean like water.
No, he means actual molecules of hydrogen and oxygen. The exact same stuff coming out of your kitchen tap, the same stuff sloshing around in the Pacific Ocean.
Okay, I have to play the skeptic immediately here.
Right.
Because I'm holding a glass of water right now. It flows, it splashes, it freezes into ice, it boils into steam. Space is a vast, empty, freezing cold vacuum. It doesn't splash. How can you build an entire universe out of water molecules without it just freezing into a giant cosmic iceberg?
It comes down to structure versus phase. The paper leans heavily on something called the asymmetric hydrogen bonding rule. This is the precise mechanism that allows the structure to exist even in a vacuum.
Break that down for us. What does that actually look like at the atomic level?
Okay, visualize a single water molecule. You have one big oxygen atom and two smaller hydrogen atoms. It looks like Mickey Mouse ears. In a group of water molecules, the hydrogens want to stick to the oxygens of their neighbors. That attraction is called a hydrogen bond.
Right, that's why water has surface tension. It wants to stick to itself. That's why a belly flop hurts so much.
Correct. But the lattice structure relies on a specific rule, asymmetry. Each molecule has one strong bond and one weak bond connecting it to the broader chain.
Just one of each.
In the primary lattice chain, yes. It creates a very specific directional linkage. Strong, weak, strong, weak. And the key detail, and he cites recent research by Hunger et al. From 2024 here, is that this rule is invariant.
Invariant meaning it doesn't change.
It doesn't change based on its phase. Whether you are looking at a hot cup of tea, a solid block of ice, or, and this is the really big leap, the interstellar medium, the underlying geometry of that connection remains constant.
Oh, wait a second. The interstellar medium is a vacuum. There is practically nothing there. That is the literal definition of outer space.
That is the exact incorrect assumption standard physics makes that the paper is trying to correct. The paper argues that emptiness is a misconception based on density. We confuse empty with diffuse.
Give me the numbers on that. How distinct are we talking?
Okay, let's look at liquid water. In a glass of water, you have a density of about 3.3 times 10 to the 22nd power molecules per cubic centimeter. It is packed incredibly tight. The molecules are constantly jostling, and the bonds are breaking and reforming rapidly, about 1 trillion times a second, 10 to the 12th hertz.
1 trillion times a second. That sounds like absolute chaos.
It is highly dynamic, but the structure persists. The lattice connectivity remains completely intact, even as the individual partners swap out. Now, look at the interstellar medium. Out there, the density drops to less than 1 molecule per cubic centimeter.
That is a staggering difference,
Yeah.
from 10 to the 22nd down to less than 1. That's why we call it a vacuum.
It's incredibly diffuse. But the argument is that the lattice thins out, but it never actually breaks. The geometric character, that asymmetric bonding chain we talked about, stretches across the void.
So it's sort of like a spider web.
That's a perfect analogy. Imagine a spider web made of highly elastic silk. You can ball it up super tight in your hand, that's liquid water, or you can stretch that exact same amount of silk across an entire football stadium. The web is still there, the connections are still continuous from one side to the other, but it's mostly empty space between the strands.
So if the lattice exists, space-time exists. The paper argues that we are literally swimming through the cosmos. We just don't feel the drag because the medium in space is incredibly thin compared to the dense water we drink.
Exactly. And this connects the ocean to the stars in a way I have never really thought about before. It implies that the water on Earth is just a high-density clump of the exact same stuff that makes up the vast space between galaxies.
It effectively removes the barrier between matter and void. And it says the void is just matter spread out really, really thin.
Which is a profound shift in perspective. Standard physics treats matter and space as two entirely different things. Matter is the actors, space is the stage. Holmes says no, the stage is made of the exact same wood as the actors.
It's a beautiful image. But as we know, science needs more than beautiful images. It needs proof. It needs to explain the things we already observe and measure.
Which brings us perfectly to Section 2, the 5 pillars of evidence. Holmes lays out 5 distinct arguments for why this isn't just a fantasy. He takes the hardest, most stubborn problems in physics and tries to solve them strictly using this water lattice.
Let's start with Pillar 1, the Schwarzschild metric.
This is the big one for the theorists.
Huh.
The Schwarzschild metric is the mathematical solution to Einstein's field equations that describes a black hole. It's the gold standard. If you are proposing a new theory of gravity, it absolutely must reproduce this metric. If it doesn't, you throw it in the trash.
And standard physics does this with the geometry we talked about.
With the Riemann curvature tensor. It's very complex, abstract differential geometry. It describes how the coordinates of space and time warped. But here is what is corrected. Holmes derives the exact same metric, mathematically identical, but he does it by treating gravity as a refractive index.
Refractive index, that's optics. That's light passing through a glass lens.
Exactly. Think about a glass of water again. When light enters it from the air, it slows down and it bends. That is refraction. Holmes argues that a massive object, like a planet or a star, puts the surrounding water lattice under radial strain.
It pulls on the web.
It compresses the lattice toward the center, and just like compressing glass changes its refractive index, compressing the space-time lattice changes its refractive index.
So when we normally say gravity bends light, Holmes is saying no, the varying density of the water lattice refracts light.
Yes. He derives the formula for the refractive index as a function of radius, and lo and behold, it creates the exact same line element as Schwarzschild, 1 minus 2 gm over c squared r.
Why is that so significant, though? I mean, getting the same answer with different math happens sometimes in physics.
It is significant because of the physical implications. It explains why the phenomena happen mechanically, not just mathematically. Take gravitational time dilation. We know time moves slower near a massive object. Standard physics says time is curved, which is incredibly hard to visualize. How do you curve a second?
Yeah, my brain usually starts to hurt when I try to picture a curved minute.
The water matrix says time moves slower because all physical processes are propagating through a medium that has a higher refractive index. It's like trying to run through waist-deep water versus running through the air on the beach. You physically move slower. The clock of the universe ticks slower because the medium is thicker or more strained.
That is incredibly intuitive. It turns a philosophical, abstract problem into a tangible, mechanical one.
And it completely solves the factor of 4 problem.
What is that? I haven't heard of that one.
This is a famous historical stumbling block. In the early days of relativity, there was a real struggle to calculate exactly how much starlight would bend around the sun. Newtonian physics predicted a certain amount. Einstein predicted double that amount. A factor of 4 comes into the derivation related to how space and time interact. Many alternative theories of gravity fail to get this number right. They only get half the deflection.
And the water matrix gets it.
It recovers the full factor of 4 completely naturally because the refractive index affects both the time component, meaning the speed of light slowing, and the radial component, meaning the path length. It accounts for the full bending without needing any abstract curvature whatsoever. It essentially says Einstein got the number perfectly right, but he got the mechanism wrong.
Okay, so pillar 1 is basically the math works, but I'm a show-me kind of person. I want to see this in a lab. I want to see water doing something genuinely weird.
Then you are going to love pillar 2.
Yep. This
is the Hugh et al. Experiment from 2013.
The paper actually calls this the smoking gun laboratory evidence.
It really is. So Hugh and his team weren't trying to prove the universe is made of water. They were just studying fluid dynamics and water waves. They built a tank with a specific bottom structure, a series of Helmholtz resonators.
Resonators, like tuning forks.
A similar idea, yeah.
Yeah.
They are split tubes that vibrate at a specific frequency when energy passes over them. They sent water waves across this array, and they rigorously measured the effect of gravity acting on the waves.
Effective gravity. That phrasing implies gravity isn't always just 9.8 meters per second squared downwards.
In this specific experiment, it wasn't. At a specific frequency range, right around 4.4 hertz, the effective gravity dropped. And then, as they tuned it further, it actually went negative.
Wait, negative gravity?
Negative. The waves stopped propagating completely. The medium effectively rejected the transmission. The gravitational coupling actually reversed sign.
That sounds physically impossible. If gravity is negative, shouldn't the water literally float up to the ceiling of the lab?
It's strictly for the waves propagating through the structure. The restoring force that usually acts downwards, which is gravity, was canceled out and reversed by the resonant response of the structure beneath it.
So they didn't invent anti-gravity technology, they just They tuned the frequency.
They tune the structure the waves were moving through. And this is the massive fundamental insight Holmes draws from it. He says, look at this. Gravity in water is tunable. It is structure dependent. It is frequency dependent.
And since his foundational theory is that the universe is water,
He argues that what we call gravity in empty space is just the bulk coupling of the lattice. And if we could change the structure or frequency of the lattice, we could theoretically modify gravity. It points out that standard physics is incorrect to view gravity as an immutable fixed law. It's actually a flexible property of the medium.
that is mind-blowing. It takes gravity from being an untouchable law of nature to being a mechanic, something you can literally tinker with. It suggests that if you can match the resonance of the vacuum, you can control how you fall through it.
Exactly. And that thought process leads directly into pillar 3, which is unification.
This is the holy grail of physics. People have been trying to combine gravity with the other fundamental forces, the strong nuclear force, the weak force, electromagnetism, for a century. Einstein famously spent the last decades of his life dying trying to do it.
And standard physics continuously fails because gravity is so much unbelievably weaker than the others and seems to follow entirely different mathematical rules. Standard physics has the standard model for particles and general relativity for gravity. They don't talk to each other. They're like two entirely different operating systems trying to run the same computer. It's a prime example of the incoherent theory era Holmes is criticizing.
And Holmes proposes something he calls one medium, one variable.
The medium is water. The variable is frequency.
Think about it this way. You have a pool of water. You can send a slow, massive, rolling swell across it. That's a very low frequency. You can also vibrate the water with a tiny ultrasonic emitter. That's a very high frequency. Or you can shine a laser beam through it.
The water is exactly the same substance in all three scenarios. The energy moving through it is what's different.
Holmes breaks it down like this. The strong force, the force that binds quarks and protons together in an atom, is simply the water lattice responding to extremely high-frequency coupling. We are talking tiny nuclear scales. The nodes of the lattice are packed impossibly tight, and the vibration is intense.
So it's essentially a grip caused by high-speed, localized vibration.
Yes. Then the weak force corresponds to frequencies that allow state transformation. These are the frequencies that let the lattice rearrange itself slightly, which allows for particle decay and mass generation. Electromagnetism is simply the propagation frequency, that's light traveling through the lattice. And gravity. Gravity is the bulk coupling. It's the extremely low frequency response of the entire massive lattice structure, stretching and compressing over huge distances.
The paper makes a really elegant comparison to sound here, right?
Yes. It says sound travels faster in water than in air. Light travels slower in water than in a vacuum. The medium dictates the response. The real aha moment here is that we don't need 4 completely different abstract fields for 4 different forces. We need one physical field, the water lattice, responding to 4 different musical notes.
It's like a symphony. Gravity is the low, slow bass line, and the strong force is the frantic, high-pitched violin.
And we have been confused for decades because we thought the violin and the bass were playing in 2 completely different concert halls. Holmes says, no, it's the exact same stage.
This correction is hugely significant. Standard physics invents a theoretical gluon to carry the strong force and a photon for electromagnetism and a hypothetical graviton for gravity that we've never found. Holmes says you don't need all these different imaginary force carriers. You just need the physical lattice vibrating at different speeds.
Let's move on to pillar 4, because even if water can carry these forces, isn't water, well, passive? It just sort of sits there until something moves it?
That is the common human intuition. But rigorous fluid dynamics says otherwise. This brings us to the paper by Zekri, Koropkin, and Cooker. They analyzed active gravitational response.
What does that actually mean, active?
They mathematically demonstrated that when an object enters water, gravity doesn't just statically pull the object down. The gravity acting on the water itself significantly modifies the flow around the object. It changes the water from a passive inertial medium into an active responder.
The water fights back.
It reacts dynamically to the intrusion. The gravitational correction to the force actually grows over time, specifically as the tet to the power of 3/2. It's not just a static weight. The medium actively reorganizes its force transmission to focus on the object moving through it.
And this connects to the hydrophobic and hydrophilic simulation too, right?
Yes, the Singh and Powell simulation from 2023. This is absolutely crucial for understanding how the lattice physically grabs matter. They showed that a hydrophilic sphere, one that chemically bonds to water, experiences significantly more drag than a hydrophobic one, which repels water.
Because the hydrophobic one breaks the lattice structure.
It creates a microcavity. It physically severs the connection. This implies a massive correction to how we view mass. It implies that mass or inertia might actually just be a measure of how well an object connects to the space-time water lattice. If you are deeply connected, the lattice drags on you heavily. That's what we experience as inertia. But if you could somehow sever that connection,
You'd be totally massless.
theoretically, yes, you would slip through the medium without any drag whatsoever. This redefines mass not as an intrinsic magical property of an object, but as a relational property, a relationship between the object and the water lattice.
Okay, let's look at Pillar 5, the tides. This one felt the most grounded in everyday reality for me. We literally see the tides every day on the beach.
But we rarely stop to think about the planetary energy budget involved. The paper points out a genuinely staggering statistic. Earth's oceans dissipate about 3.5 terawatts of tidal energy. That accounts for 95% of the total tidal dissipation of the entire planet.
And the solid Earth?
The solid Earth accounts for 99.95% of the planet's total mass. It's unimaginably huge compared to the oceans. But it only dissipates 5% of the tidal energy.
That is a 17-to-1 ratio. Why in the world is water so much better at catching tidal energy than solid rock?
Standard science just waves its hands and says friction and sloshing. Holmes says efficiency. He argues that the water lattice is structurally tuned to couple with gravitational forcing. The asymmetric hydrogen bond network we discussed earlier is a perfect, highly sensitive receiver for the moon's gravitational signal. Rock is a rigid, locked crystal. It doesn't have that responsive, flexible lattice structure.
So the oceans are basically acting like a giant, perfectly tuned antenna for gravity.
That is exactly the claim. It's not just that water flows easily, it's that water couples efficiently. It implies that water is doing something very specific with gravity at a molecular level that other forms of matter simply are not capable of doing.
All right, so we have deeply established the lattice at the micro level. We have established gravity as an optical refraction. We have established the unification of forces. Now, let's zoom way, way out. Let's talk cosmology. Section 3, resonant shell cosmology.
This is where the theory tackles the origin story, the Big Bang, and the ultimate shape of the entire universe.
And it aggressively replaces the standard expanding balloon model with something completely different.
A resonant shell. Holmes proposes that the universe is a closed FRW region. Imagine an unimaginably giant sphere bounded by a thin, highly reflective shell.
A physical mirror at the very edge of the universe.
Effectively, yes. A reflective boundary. And this changes absolutely everything about how we interpret the oldest signals we receive from deep space. Take the cosmic microwave background, the CMB.
The static we see everywhere we look in the sky. The famous baby picture of the universe.
Standard view, which Holmes points out is incorrect. It's the cooling, fading afterglow of the Big Bang explosion. Corrected view. It is a standing wave pattern.
Explain standing waves for us.
Think of a guitar string. When you pluck it, it vibrates in a very specific geometric shape. It has points that don't move, called nodes, and points of maximum movement, called antinodes. Or think of sound echoing in a perfectly closed, tiled room. It resonates. Holmes argues the CMB is literally the electromagnetic resonance of the universe bouncing back and forth off that outer shell.
And does the math actually fit that wild idea?
Surprisingly, perfectly well. The acoustic peaks in the CMB data, the bright and dark spots in the map we've all seen follow a precise 1:2:3 ratio. This is exactly the mathematical signature you expect from cavity eigenmodes. It's the textbook math of resonance inside a closed box.
So the universe is literally a musical instrument.
And we're living deep inside the sound box.
What about dark energy then? The universe is accelerating, right? Galaxies are flying apart faster and faster. Standard physics says there is this mysterious dark energy pushing everything apart.
Holmes says no. It's surface tension.
Surface tension, like a soap bubble.
Exactly like a soap bubble. If the shell is under immense tension, that tension exerts an outward force on the interior volume. The math in the paper shows that this surface tension creates an apparent acceleration that mimics the effects of dark energy perfectly.
So we absolutely don't need to invent a new, invisible, undetectable energy fluid to make the math work.
Yeah.
We just need to acknowledge we are living inside a bubble.
He claims this model fits the Planck data, which is the absolute gold standard of cosmological measurements, with a statistical chi-square value comparable to the standard model. But and this is the crucial part, with too fewer parameters.
Simpler is always better in physics.
In science, usually yes. If you can explain the exact same complex data with fewer wild assumptions, you are winning the argument. Occam's razor heavily suggests the simpler solution is often the correct one. Standard physics requires dark energy and dark matter, two massive things we have never directly observed in a lab to make their math work. Holmes needs water and surface tension, two physical things we understand intimately.
I want to touch on section 4, the holographic boundary, because he gets very, very specific about what this shell or screen is actually made of.
He identifies a highly specific wavelength, 350 nanometers,
Which is UV light, roughly.
near ultraviolet. The exact frequency is 8.56 times 10 to the 14th hertz. The paper identifies this specific number as the sp3 hybridization energy of water.
Okay, chemistry flashback time. Hybridization is how the electrons arrange themselves in orbital shells to bond, right?
Yes. And at this precise frequency, water achieves a totally unique state. Zero reflectivity. It becomes perfectly 100% absorbing.
So if you shine 350 nanometer light at water in this exact state,
It doesn't bounce back at all. It is captured completely by the molecule. Holmes argues this chemical property creates a natural holographic boundary, a screen that captures all cosmic information hitting it. It's not an abstract mathematical wall at the edge of infinity. It's a physical property of the water absorption spectrum. The edge of the universe is rigidly defined by the frequency where the medium stops reflecting and starts absorbing.
that is wow. That is wild. It ties the microchemistry of a single water molecule directly to the macro boundary of the entire cosmos.
It connects the absolute smallest scale to the absolute largest scale in a very direct, falsifiable way. It implies the universe has a specific size or limit strictly dictated by the physical properties of water.
Okay. We have covered the theory in depth, and it is a beautiful, cohesive, unified picture. But as we know, beauty isn't necessarily truth. As we said in the intro, we need to verify this. A theory needs to be testable. So let's look at section 5, testing the theory.
Falsifiability. This is arguably the most important section of the paper. A theory that cannot possibly be proven wrong isn't science, it's just religion. Holmes offers several very specific ways to prove him completely wrong.
Let's go through the big ones. He mentions anomalous light deflection.
Right. Remember we said the lattice recovers the factor of 4 for light bending around a star? Well, because it is a physical lattice and not perfectly smooth abstract geometry, there should be a tiny, tiny graininess to the bending. A residual refractive contribution that standard relativity says shouldn't be there.
How tiny of a graininess are we talking about?
Approximately 2 micro-arcseconds.
Can we even measure something that small right now?
We are right on the verge of it. He specifically points to the Gravity Plus instrument at the VLTI, the Very Large Telescope Interferometer. It is scheduled to come fully online around 2026. He puts his cards on the table. He says, look at that data when it comes in. If that 2 micro-arcsecond anomaly is there, it heavily supports the physical lattice. If the bending is perfectly smooth, general relativity wins, and the water matrix is wrong.
That is a remarkably brave prediction. He's putting an exact number on it for a future instrument.
He is. Then there is a test he calls vibrational frequency shifts. If gravity is truly physical strain on the lattice, then water molecules physically near a massive black hole should be stretched tight. Their vibration, specifically what chemists call the OD stretch frequency, should shift noticeably.
Like tuning a guitar string up so it plays a higher note.
Exactly like that.
Hmm.
He predicts a specific shift of 10 to the minus 3 that should be detectable by the James Webb Space Telescope, looking at water signatures near Sagittarius A star, which is the supermassive black hole at the center of our galaxy.
And the water absence test. This one fascinated me.
This is the most purely logical one. If space-time equals water, then no water equals no gravity.
So if we find a completely dry spot in the universe,
He suggests aiming our instruments at cosmic voids. These are unimaginably huge, empty areas in the universe between galaxy clusters. If we find a region in a void that is truly, entirely devoid of water, no vapor, no ice, nothing, we should see highly anomalous gravity. The gravitational coupling should disappear entirely or drop significantly below what the sparse surrounding mass would predict.
and if we see normal standard gravity operating there anyway,
Then the theory is dead, falsified on the spot.
I really appreciate that he puts that clearly on the table. He isn't moving the goalposts so his theory can always survive.
He also mentions late ISW suppression. It's a highly technical correlation in the CMB temperature data relating to dark energy. He predicts a 30% drop compared to standard theory predictions. Again, a very specific, testable number.
Let's talk about the human element here as we
Yeah.
get into section 6. The author, Garrick Ramsey Holmes, because he writes in a very distinct voice.
He certainly does. It's definitely not the dry, passive, heavily sanitized voice of a typical peer-reviewed academic paper. He writes things like, I'm a futurist, and it isn't mine. It belongs to everybody.
It felt very inviting to the reader, but also noticeably defensive at times.
Defensive, yes. He clearly anticipates the academic rejection. He writes, filing a claim under a category you're already familiar with is not engagement, it's avoidance.
He is directly calling out the scientific community's tendency to just completely ignore outsiders who challenge the core dogma.
He heavily challenges them. He essentially says, go ahead, find a prior paper that identifies water as spacetime, successfully derives the Schwarzschild metric from it, unifies the fundamental forces, and mechanically explains the planetary tides. You will not find it, because it does not exist.
He is firmly staking his claim. I built this comprehensive framework. Prove me wrong with data, not with philosophy.
And we absolutely have to be impartial here. As the expert on this deep dive, I have to reiterate loudly, this is not currently accepted physics. The standard model, despite its glaring flaws, works exceptionally well for a whole lot of practical engineering and astronomical observations.
But the standard model fundamentally has holes.
It does have holes. It has the silence at the center about what space-time actually is. It has the massive dark matter and dark energy placeholders taking up 95% of the universe. It has the complete mathematical incompatibility of gravity and quantum mechanics.
And Holmes is stepping into that silence and saying, I fixed the holes. The underlying answer to all of them is water.
He is saying that the mathematical map of standard physics doesn't match the physical territory of reality because the map incorrectly assumes the territory is empty geometry. He strongly claims the territory is a tangible physical substance.
It's a profound, not matching up situation. Standard physics says the vacuum is empty. The water matrix says the vacuum is completely full.
And ultimately, only the physical tests, the gravity plus data, the JWST observations, can definitively decide who is right.
So as we wrap up this deep dive, I'm going back to look at that glass of water sitting on my desk.
It's really hard not to stare at it differently after reading all this.
If this framework is true, if Holmes is actually right, then I am holding the fundamental building block of all reality in my hand right now.
You are literally holding the medium of gravity. You are holding the dense optical lens that bends starlight across galaxies. You are holding the high-frequency glue that binds the nucleus of the atom together.
And when I walk outside tonight and look up at the dark night sky,
You aren't looking out into a terrifying, empty void. You are looking deep into an ocean. A very, very thin, beautifully lattice-structured ocean.
and we are all just swimming through it.
We're just swimming.
This has been an incredibly mind-bending deep dive. I want to leave you, the listener, with that specific thought today. The universe might not be a cold, dark, empty, terrifying place at all. It might be a resonant, vibrating, deeply connected aquatic shell. And the answer to the biggest, most complex mysteries of the cosmos might literally be sitting right there in your kitchen sink.
Keep your eyes closely on the astronomy data coming out in 2026. The real answer is hiding in the micro-arc seconds.
Thanks for joining us on this deep dive. We will see you on the next one.